Hey guys, this tutorial is going to be a look at some of the fundamental concepts of geometry in Rhino and thus what we have access to in Grasshopper. Now this tutorial will explain things that are good to know if you're using Rhino, so it's not a Grasshopper specific tutorial, but I will be explaining some of it in terms of Grasshopper terminology, so feel free to follow along if you want, otherwise do what you want. I should also note that you don't necessarily need to do anything in this tutorial. This will be just me explaining some fundamental concepts, so you don't need to actually um, have your Rhino and Grasshopper open if you don't want to. Alright, cool. So without further ado, um, the main type of geometry that you work with in Rhino is called NURBS. And NURBS stands for Non-Uniform Rational Basis Spline, or a B-spline. And so these are just a specific kind of geometry that were discovered in, I don't know, the 1950s, or between the 1950s and 1970s, and they're governed by an incredibly complex set of mathematical equations far beyond my head, but we don't need to know all of that to understand how they work. I'm just going to explain to you what you need to know. So the most important information about a curve that we can access that by hitting typing in rebuild. And so all we need to know about is the point count and the degree. So the degree is kind of like a sharpness of the curve, or also like the amount of influence that a point has on a curve. So any polyline, so any curve made of straight lines, is going to have a degree of 1. And then and so the degree can be basically any number. Generally you'll get either a degree 1 curve, a degree 2 curve, a degree 3 curve. You can get a 4, although they're not really used that widely, or this one is a degree 5 curve, and so on and so forth. And so if I turn all of these points on using the points on command, okay, so for a degree 1 surface, the way that I like to think about it is if you move this 1 point, it only has 1 point of influence. It won't do anything to any geometry beyond either of these points. If you're meddling with a degree 2 curve, you'll have 2 sort of degrees of influence. So it'll manipulate any geometry tied to this point and also this one. A degree 3 curve will have 3 degrees of influence. So we're kind of getting influence on this point here, and a tiny bit bleeding into this point here. And then a degree 5 curve has 5 degrees of influence. So from this point to this point to this point to this point. And you'll notice that the higher your degree of curvature, or the higher the degree of the curve, the more sort of spaced out your points get, and that's just a factor of calculating a NURBS curve. The other really important thing to note about a NURBS curve, I'm just going to make another curve over here really simply, is you cannot, the degree has to be less than the amount of points in the curve. Actually, let me put that the other way. There needs to be more points in the curve than the degree of that curve. So for instance, if I were to rebuild this curve, actually let me just before I do that, I'm gonna cycle through the different degrees so we can see what's going on here. So this is the degree 1 representation of this curve. This is degree 2. This is degree 3. And so at degree 3, we sort of get the most natural shaping of that curve. And in general, degree 3 curves are the best curves to work with. I say best in a very sort of loose sense of the term. Alright, we'll keep going. We'll try degree 4 and degree 5, and we don't really need to go beyond that. So you can see our points are going to get really spaced out. So we'll just we'll bring this back, sorry, to degree 3. Alright, now what else do we need to know about curves? It's really important how you space the control points of your curve out. And so for this we're gonna dive into Grasshopper so I can illustrate this. I'm gonna build a curve with 4 points. So that's my first curve, and then I'll build another one with maybe a tiny bit of spacing over here, and then a whole lot of spacing in the middle, and then a tiny bit at the end. Then we'll do another curve with huge space in the, between the first and second point, and then really small spaces between the third and fourth point. Alright, now we're gonna bring these into Grasshopper as pieces of curve geometry, and I'm gonna set multiple curves. So 1, 2, 3. Now, as I evaluate these curves, you're going to notice something. I'm just going to remember we reparameterize our curves so that it turns our curve, whatever length it is, into a 0 to 1 space. So that way, if we're using a slider, if we're evaluating the curve, the reparameterized curve at 0, it's always going to be here, and at 1, it's always going to be here. Alright, so we'll set this back to 0, plug it in. Now watch carefully what happens with this slider. In fact, I'll just turn the control points on so that you can really understand what's going on. Okay. Did you notice that? We get a very sort of interesting result in the way the curve or the evaluation works along the curve. Basically, if I'm going to evaluate it at 0.5, it will basically every single point on the curve has like a weight to it, and so the longer the spaces between the curves, the I guess the more drawn the point will be to where, or the more drawn the evaluation point will be to where there's more points. So if we were to bring this to 0.25, you'll see our point on this third curve is pulled really far along this curve, whereas along this one it is probably about a quarter of the way along that curve, and along this one it's still dragged, it's still a bit sort of retarded towards the 2 points at the beginning of the curve. Now, if you do bring your curves in to Grasshopper like this, it's not too much of an issue because we also have the rebuild curve in Grasshopper too. And so rebuilding a curve before you manipulate it is really, really good to do. Because if we want to now grab the control points of this curve, you can see that it's Grasshopper's really spread them out a lot nicer. And so with this degree, we also have a couple of different parameters that we can control. We can control the degree of the curve, and we can also control the number of points. And if we want, we can we have some sort of control over the tangents of the curve as well. Alright. So now let's look at what happens if we were to loft these 3 curves together. Okay, now that's alright, but that's not quite what I'm showing you just yet. If we were to take an ISO trim of this curve, of this surface, sorry, and for that I need to use a divide domain squared. Don't worry about what these components are at the moment, that's not too fundamental to what I'm trying to explain. Basically, we're going to look at how this surface is going to be divided up if we don't sort of create our points properly. Or maybe you would want to do it like this because you'd want to achieve this sort of effect. Okay, so I'm going to turn the points on again, and you can see once again these the point structure is really affecting how our surface is divided. It's really skewing the points to like towards these 3 points here on the third curve, and we're getting some really weird spans along here in the second curve, whereas in the first curve we're getting really nice spans between our 4 points. So if we were to put these rebuilt curves into the loft, you'll see what we get are really nice spans across our entire curve, because Grasshopper realizes that we want to, or not, Grasshopper doesn't realize, we've rebuilt the curves so that Grasshopper will now deal with them in a much nicer way. Alright, so just like how curves have a degree value, surfaces also have a degree value, because surfaces are NURBS geometry too. So we're going to create a sphere. I'll just drop that down. Okay, and so by default, the sphere is going to have a degree value of 2. But what you also notice is that it has a degree value in each direction, because a surface has a u direction and a v direction. And so by default it's set to 2. Oh, sorry, let me just undo that. And we're going to make 2 copies of this. One there, and one there. And now we're going to rebuild this one, and we'll set it to degree 1. We'll rebuild this one, and we'll just leave it at degree 2, but we've changed the point count, so I just want to keep that consistent along all of my surfaces. And we're going to rebuild this one, and we'll make it degree 3. Alright, so you might look at this and think, oh, that looks like a poly surface because it's composed of multiple different panels. Well, no, it's not actually. It's still a surface. And the way we can tell is because as soon as we select it, it tells us it's a surface. I'm going to explain the difference between poly surfaces and surface in a little bit more time. Alright, so degree 1 is always going to create this sort of faceted look. You saw the same thing with our curve, because each of these points have basically only 1 degree of influence, as I called it. Okay, so now if we were to take this sphere and we were to grab a whole row of points, in fact, let me just deselect those because I don't want those ones, and then we were to drag this out. Actually, hold on, let me just check what happened with that. Okay, so if I were to turn points on again, and let's see what happens if I just grab these. Okay, sorry, never mind, I just got a bit distracted there. Sorry, and I undid that rebuild. Okay, so with this degree 2 surface, if we were to start pulling on some of these points, you might notice something, and that's that it gives us this really weird sort of harder edge, which is a result of the fact that it's a degree 2 surface. It's just going to do something a tiny bit weird, which is totally cool. In fact, I think, like, if that's what you're going for, that's all good. But if we were to do the same thing with this degree 3 surface, let me just deselect those points and select these. Your degree 3 surface is always going to remain 100% continuous and clean and really nice. And this is once again because of the way we deal with curvature of geometry and the way that NURBS are constructed. Your degree 3 surfaces and curves are always going to look the most natural, be the smoothest, and just all in all the nicest to work with. Alright, cool. So I'll just undo all of that. Okay, so now if we bring these surfaces into Grasshopper, actually I'll just bring them all in separately. Okay, so now we're going to use an evaluate surface component. I'm going to plug my surface in, and I'll do that 3 different times, and then I'll just use one multi-dimensional slider. Oops, and I forgot to reparameterize these. So we can, in fact, evaluate all of these surfaces along any point, or along any parameter along that surface. You'll notice that as we sort of shift along the bounds of this one, it is going to give us very sort of hard changes, or hard, how to say, let's just go with hard changes in the direction. So it's a very abrupt change along that that edge, but it's still a surface, and all of these surfaces are going to give us nice smooth results as we pan around them. Now, just to explain something, I'm going to divide the surface using a divide domain squared. In fact, did I? Yes, I've still got this here. I'll just make a copy of this, and I'm going to evaluate this surface. Oh, no, not evaluate it. I'm going to divide it into 10 chunks, and then I'm just going to deconstruct that object, or those objects, and it's going to give me a list of vertices. And so I'm just going to get a list item, plug that in, and I'll get my 4 points out, and then I'm going to create 4-point, oops, not that, a 4-point surface, and using 1 point, 2 point, 3 point, and 4 points. And then we're just going to use a brep join component, flatten that. Okay, you might be wondering why I did this, and you'll see why in a sec. Okay, so this is a surface, and this is a poly surface. Now, what's the difference between those? Well, you might think they look exactly the same, and you're not. I guess they kind of do. But there's a fundamental difference between these. We can, okay, this is the degree 1 surface, right? We can evaluate that surface, as we saw, at any which point on that surface that we want. It will give us abrupt changes between these sort of facets, but nonetheless, it is still a surface. Now, if I try to bring this in as a surface, it's not going to let me. It's just going to throw a null. So if I try to set this again, nope, still not working. Even if we were able to bring this into Grasshopper as a brep is what Grasshopper calls a polysurface. we're going to set this brep and then preview that off. If we were to now try and evaluate that surface, you'll see Grasshopper won't let us, because you cannot, because a brep is different to a surface. A brep does not have everything constructed in this sort of 0 to 1 space that we have of just a normal surface. It's constructed of multiple different surfaces, and so we lose all that information about the domain of the object as a whole. And so in general, when you're working in Grasshopper, you want to try and work with surfaces more than breps, because that allows you to work with a lot more of these functions. Basically, any of these functions that even say brep or surface will work with a surface, but not everything that says surface will work with a brep, because a brep is sort of a level higher of geometry. Alright, now one other thing that we need to talk about in terms of surfaces is what's called the genus of the surface. What this is, okay, I'm just going to make a circle here, and then I am going to make a pipe around it. Okay, so this is a surface, and this is a surface. And what the genus is basically the number of holes that object has. And so a NURBS piece of geometry can only have either a genus of 0 or 1. This is explained further on the Wikipedia article for genus. So here we have a genus 2 surface, and as you can see, genus 0, 1, 2, and 3. But NURBS surfaces, because of the way that you evaluate a surface from 0 to 1, can only be either genus 0 or genus 1. Alright. What else do we need to talk about? Yes. The final piece of geometry that I'm going to cover in this, I'm just going to, actually no, we'll just leave that, it's not too important. The last piece of geometry we're going to cover is a mesh. So a mesh is quite different to a NURBS surface or a poly surface. Let's create a mesh sphere. Oops, let me just go and find it. A mesh sphere. I'll just set this radius to 100 or so, plug that into my radius, and we also need a number of U and V spans. Alright, so this is my mesh, and so if I just turn these old objects on, we're going to show selected. I want to show these two, and then we're going to go into shaded mode. So you might look at these and think that these look like similar constructions of geometry, but a mesh is quite different to a NURBS surface, because a NURBS surface, if it's anything more than degree 1, it will try to be, it'll be continuous at any point on that surface. So it has no discontinuities. Whereas a surface, or a mesh, sorry, no matter how smooth it is always going to be made up of essentially polylines. Not quite polylines, but that's what it looks like to us. Every single edge on a mesh is completely straight. And that's quite an important difference. So the way we work with meshes is, well, actually there's some really interesting ways that we can work with meshes. I don't know if we're quite going to have time to go into that for this tutorial, but let's say that I've got a mesh like this, which looks very, very boxy. If I go into rendered mode and then just preview that off, the mesh geometry does something really interesting in terms of how it shades itself, and that it gets light information per vertex, I guess, and so that information kind of bleeds over onto neighboring faces, which is why we're getting this really weird sort of black perimeter shadow around this shape. If we want to get rid of that, we need to increase the count on our number of faces, and the higher our count, the smoother our object is going to look, and hence the more sort of, or the less of this sort of black shading you're going to get on the peripheral. And so what's really important to understand about a difference between meshes and surfaces is that meshes have this sort of resolution factor, where the smoother your mesh is, the higher resolution it is, and the I guess the better your shading will look, if that's what you're going for. NURBS to a degree, to an extent, also have this idea of resolution, but that's to do with scale. So the larger your NURBS surface is, the more resolution it's going to have, because Rhino needs to calculate every single point on that surface according to the sort of accuracy of Rhino you're working with. So this sphere that I'm working with now is only, what's that, maybe 100 millimeters in diameter, but if I were working with that at 100,000 millimeters in diameter, it could cause my Rhino to lag quite a bit, and so we need to be aware of that when we're working with scale and NURBS geometry. Alright, so now the final thing I'm going to talk about real briefly is this idea of subdivision modeling. I'm going to hide all of this. So a really popular way to work with meshes that's been developed for a lot of other programs, you don't really use it so much in Rhino, is this idea of subdivision modeling, where you start with, or you basically construct really primitive looking geometry, and then you subdivide it to get a much smoother result. And so in order to do that, we have this, you should, if you don't have it yet, you should get this program, or this plugin for Grasshopper called Weaverbird. And so it has different kinds of subdivision methods, and we're going to use this Catmull-Clark subdivision method. And so what this does is it tries to smoothen out the geometry as much as possible. Or not as much as possible, it takes the initial edges of the surface and looks halfway between each and every edge, and then deconstructs that face into 4 smaller faces, which are a lot smoother. Well, not a lot smoother, but they result in a smoother look overall. And so for this Weaverbird plugin for smoothing geometry, we can go up to 3 iterations by standard, and that'll give us a really nice smooth looking mesh to work with. And so you might not even be able to tell the difference between that and a NURBS surface, but the way you can obviously tell is just by looking at what Rhino tells you it is in the viewport, or what Grasshopper tells you it is on the output. Alright, so that's That was probably a really basic rundown of meshes, whereas we went into a bit more detail on different kinds of surfaces, the degree of surfaces, the degree of curves, and the genus, as well as various other things. I hope this has been an interesting tutorial. So cool. Have fun with it.